This video teaches you about systems of linear equations, okay? Now there's two ways to solve. First off, what we're going to do, we're going to put this sheet here off to the side. And what we're going to do is actually use a graph to get the two answers. This is the only problem we're going to use that on though. So the first equation says 2x plus 4y equals 12. And the second equation says x plus y equals 2. So that's two equations. And what we're actually going to do is we're going to find the value for x and we're going to find the value for y. And we're going to find that by graphing these two equations on the same coordinate plane here. Remember, this is the x-axis, this is the y-axis. And wherever the lines cross, the point where they cross is going to be our answer for x and y. So let's focus on this first equation here. Circle it. 2x plus 4y equals 12. Well, what form is it in? Okay. Do you have the y by itself? Nope. It's in standard form. Okay. So since that equation's in standard form, we're going to set up the xy table with the 0 for x and the 0 for y. Okay, then we want to copy that equation down twice. So 2x plus 4y equals 12. And then we're going to copy it down a second time. 2x plus 4y equals 12. So if the x is 0, we can eliminate the 2x because 2 times 0 would be 0. And then that means 4 times y equals 12. So then we will just divide each side of the equation by 4. So 12 divided by 4 is 3. So that's the first point, 0, 3. Now, if the y is 0, we're going to cross out the 4y. So 2x equals 12. 2 times x equals 12. So we're going to divide by 2. And 12 divided by 2 equals 6. Okay, so we're going to graph the point 0, 3. So x is 0, y is 3. So I stay in the middle and I just go up 3 on the y. Okay. And then we're going to graph the point, the coordinate 6, 0. X is 6, y is 0. So I go to 6 on the x. So 1, 2, 3, 4, 5, 6. Make a point. And then you need to take a ruler. I don't have a ruler right here, so I'm just going to use this piece of cardboard to draw a straight line. The line kind of has to be straight, so I'm going to set the camera down here and just connect the points. Okay, and I'm going to put arrows on each side of the line. So this equation here has been graphed. I'm going to cross it out. Now I'm going to look at the other equation, x plus y equals 2. Now again, as you can see, the equals is here. Y is not by itself in front of the equals. The x and y are together on the same side, so that again is in standard form. Okay, so we're going to use the same strategy to graph. So I make a table, 0, 0. And then I'm going to write that equation down twice. So x plus y equals 2. X plus y equals 2. So if x is 0, we can go ahead and eliminate the x term. And I don't need to divide. Y is just equal to 2. If you put a 1 in front, you just divide by 1. Now if the y is 0, we are going to eliminate the y term. And x equals 2. Okay. So I have to graph x0, y2. So I stay in the middle, I go up 2. And then I graph 2, 0. So I go 2 and 0. And now I'm going to take that straight edge and graph the points. Okay, now those two lines eventually cross, okay? And they cross right here. So I'm going to make that point and circle the crossing. So on the x line, where do they cross? -1, -2, -3, -4. So x is -4. There's my answer for x. And how about y? 1, 2, 3, 4, 5. They cross at +5 for y. So those are my answers. Okay, now we're not actually going to graph to solve these systems. We're going to use two techniques. There's this technique known as substitution. This is what we're going to use if we have an isolated variable. And then we're going to use elimination. We use this if there's no variable that's isolated. Okay, so those are the two strategies. So let's look at the first one. 4x plus 2y equals 8. That's one equation. And the other equation is y equals 2x plus 1. Now, here's the question. In either equation, do you have an isolated variable? The letter that's all by itself? Yes, you do, right here. Okay? So we are going to use the substitution method. Okay? So I'm going to write that right here. Substitution. How do you do substitution? Well, here is how. You're going to box the variable that's isolated, box isolated variable, which is y right here. And we're going to circle its equal. Okay, we're going to circle the other side. And this is known as the base equation, so write base. Okay, easy enough. Now, write the other equation and circle the variable that was isolated. And then we're going to replace that variable with its equal in parentheses. So write your other equation, the 4x plus 2y equals 8. Okay. Circle the variable that was isolated. So y was a variable that was isolated. So we're going to circle the y. And then we're going to replace that y with its equal in parentheses. So we're going to start with a little parentheses. So 4x plus 2. And when I come to that variable, that circle, I make a parentheses. That's empty. And then equals 8. Now, we have to fit two things in that parentheses, the 2x and the 1. So I'm going to make that parentheses wider. So 4x plus 2 equals 8. And then I replace it with the y's equal. I had a y there, and that's equal to 2x plus 1, so I put 2x plus 1 in there. Okay, now we can solve the equation that we have for the x, because both letters now are x's. So I have two x's, a coefficient of 4 and a coefficient of 2. We are going to have to use our distributive rainbows. Okay. So I have the 4x, I'll just drop that down, and then I need to multiply 2 by 2x, which is 4x, and 2 times 1, which is 2, and that equals 8. And we have multiple of the same variable, but they're on the same side, so I'm going to make my adding pyramid. I do not balance it. I just make a little note that I connect them and just add them. 4x plus 4x is 8x. And then we have to add 2. And then equals 8. Okay, I need to undo the plus 2 by minusing 2. And 8x then equals 6. And then I'm going to divide both sides by 8. And 6 divided by 8 is a decimal. That's okay. It's 0.75. So x equals 0.75. And I have my answer for x. Okay. Now for the second answer, we simply plug the first solution into the base equation, okay? Because it's very easy to use the base equation. So here's the base, and I know that x is 0.75, so I want to parenthesize the x, scribble it out, and just replace it with 0.75. Okay? So 2 times 0.75 plus 1 equals y. So all I need to do is find what 2 times 0.75 plus 1 is. Okay, 3.5. Wait a second, I screwed that up. 2 times 0.75 plus 1, 2.5. And that is the answer. Okay, my next system, x equals negative 3y plus 1, 2x minus 4y equals 24. Do you have an isolated variable? Yes, you have the x, so we're going to use the substitution again. Now box the isolated variable and circle its equal. This is known as the base equation. Now write the other equation, 2x, put that as plus negative 4y equals 24. Okay. Now, whatever the isolated variable was, in this case it was x, we're going to circle x this time, okay? Because we write the other equation and circle the variable that was isolated, and in this case that isolated variable was the x. Now replace it with its equal in parentheses. So remember how we do that. We go 2 parentheses, just leave that empty for now, and then keep going, plus negative 4y equals 24. And widen that parentheses because you have two terms you have to fit in there, the negative 3y and the plus 7, because that's what x is equal to. So 2 and then plus negative 4y equals 24. And we're going to put negative 3y plus 7. And now since I have matching variables, I can solve. I am going to have to use my distributive property rainbows. So 2 times negative 3y is negative 6y. And 2 times 7 is 14. Plus negative 4y equals 24. And again, I have multiples of the same variable, but they're on the same side. So I do my adding pyramid. Don't plus 4, it's adding. You don't balance one side. So negative 6 plus negative 4 gives me negative 10y. And then I have that 14 that needs to be added before I get to equals 24. Okay, I need to undo the plus 14 by subtracting, and that is 10. So negative 10y is equal to 10. And then I divide both sides by negative 10, and that's negative 1. Okay, and that's your answer for y. Now for the second answer, simply plug the first solution into the base equation. So here's the base equation. We don't want to use that one because that doesn't have the x by itself. Okay, I have my answer for y, negative 1, so I parenthesize the y, just put negative 1 in there. So x is equal to negative 3 times negative 1 plus 7. I got 10. And that is how you solve a system of equation with substitution. We did that last year. Okay, now the next problem. 3x plus 4y equals 9. Negative 3x minus 2y equals negative 3. Okay. First off, do you have an isolated variable? This time you do not, so we cannot use substitution. We need to use elimination. Okay. No variable is isolated. First thing you do, I'm going to circle the x's and the y's. See if there is a match of absolute values in front of the x or the y variables. If not, we need to multiply each equation to get a match. So what's the absolute value of 3? 3. What's the absolute value? That means how far is 3 from 0 on a number line? That's 3 places, and that's 3 places. So I have a match right there. Okay, I don't have a match here, but I found my match here. Okay, so I do not need to multiply. So I'm going to write in this box, no multiplying necessary. Now we add the equations together to find the first solution. So I'm going to write add. So I add the 3x and negative 3x. Well, 3 plus negative 3 is 0, so we can eliminate the x from the system for now. And then I add 4 to negative 2, and that's 2, so 2y. And then 9 plus negative 3 is 6. Now I can divide by 2, and y equals 3. So I have my answer for y. It is 3. Now getting the second answer is just a little bit more work than it was on the substitution. Getting the first answer is easier on elimination, I find, but getting the second answer is harder. You're going to plug the solution, and that means the 3 for y, into one of the two original equations to find the other solution, okay? Plug the solution into one of the two originals to find the other solution. So I usually like to just copy down the top equation. 3x. I know I crossed out 3x, but it's back in play now. Plus 4y equals 9. Okay. Since I have my answer for y, I scribble out the y and put a 3 there. And that means I need to take 4 times 3. So I have 3x. 4 times 3 is 12, plus 12 equals 9. Okay? Then I undo the plus 12 by minusing 12. 9 minus 12 is negative 3, so 3x equals negative 3. And divide by 3. And that gives me negative 1. So x is negative 1, y is 3. Okay, my next problem. Do you have an isolated variable? Now, at first glance, you might say, yeah, the x is isolated. No, it's not, because there's a 3y being added to it. So, again, there is no isolated variable. So this is another elimination. I'm sorry I did not write elimination up there. I should have. Okay? So we need to use the elimination side of the sheet. Use if no variable is isolated. Now see if there's a match of absolute values in front of the x or y variables. If not, you need to multiply each equation to get a match. Okay. Well, first off, I circle the x's and the y's. Now this x would need a 1 and this y would need a 1, so I can see what the coefficients are. Okay. The absolute value of 1 is 1. The absolute value of 2 is 2, so that's not a match. The absolute value of 3 is 3. The absolute value of negative 1 is 1. So that's not a match either. I know this is a match, but I need these to be a match. So we are going to have to multiply each equation to get a match. And what you do is this. You put dot, 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 dot. Now, let's look at the x's. What's the bottom coefficient number in front of the x? It's 2. So we're actually going to multiply the top equation all by 2. Whatever we see first here with the x, we're going to multiply the top by that. And what do we have in front of the x on top now? 1. So we're going to multiply 1, 1, 1. So 1x times 2, and then I go over here and make 2 new equations. So 1x times 2 is 2x. 3y times 2 is 6y. 7 times 2 is 14. Again, whatever the bottom number is in front of the x, we're going to multiply the top by that number, all 3 terms. So 2, 2, 2, 2, 1, 1, 1, 1. Okay, 2x times 1 is 2x. Negative 1y times 1 is negative 1y. And then 7 times 1 is 7. And now I have a match here with the x's, okay? So match. Okay, now we add. But there's a problem here. 2 plus 2, that's where I have my match, and 2 plus 2 is not 0, it's 4. So what you do is you need to switch the signs of all these terms on the bottom, okay? Because when you add 2 and 2, it's not 0 yet. So if I don't have 0, I do a sign switch. I change all the terms on the bottom to their opposite, okay? So that 2 is positive. Well, now it's going to be negative. That 1 right there is negative. Now that's going to become a positive. And only do this on the bottom. We only want one of the equations to switch. Okay. The opposite of positive 7 is negative 7. So you add, but if the match doesn't add to 0, okay, meaning they're not opposites of the same, you're going to have to switch the signs on the bottom equation. Okay. Now, 2 plus negative 2 is 0. Okay, so I can cancel that. 6 plus positive 1 is 7y. And then 14 plus negative 7 is 7. Okay, now I divide by 7. And 7 divided by 7 is 1. So y equals 1. Okay, now plug that solution into one of the two originals to find the other solution. Okay, so let's go at the top. I'm just going to copy 1x plus 3y equals 7 down. 1x plus 3y equals 7. Okay, and now I have y equal to 1, so get the y out of there, replace it with the answer we got, and I have 1x. 3 times 1 is just 3. And I circle 1x, I minus 3. And 1x equals 4. And I don't need to divide because it's a 1x, so x is 4. So again, on elimination, you need to see if you have an absolute value match. We didn't, so we took this number, times it to the top, this number, times it to the bottom. And even if you get over here, if they don't add to 0, if you have a match but they don't add to 0, you just switch all the bottom signs to the opposite. It's positive, so that went negative. That was a negative, that went positive. That was a positive, that went negative. And then when I add them together, 2 plus negative 2 is 0. Okay?